Hello everyone. In this tutorial I'm going to show you how to calibrate the magnetometer on your rover. Doing so will allow it to use localization from the IMU much more effectively. I'm going to step through carefully all the things you need to do, but let me give you a quick overview. We're going to SSH into the rover. Then we're going to load some Arduino code from Pololu to calibrate the rover to read the min and max values as we rotate the robot in space physically. We're going to take those min and max values and then modify the Swarmathon Arduino code that is already on your rover, and that will help the robot account for the GPS magnet, for metal that's on the rover. Turns out that every rover has different magnetic interference properties, and so this has to be done individually on each rover. When you come to the competition, or when you send your rovers to the competition, we will make sure that we calibrate the Kennedy Space Center house rovers so that they accurately localize. But you'll need to localize and calibrate your own rovers for your own testing and for your own code development. Alright, let's get started. In order to calibrate your rover, we'll have to SSH into it, so connect it to a wireless network that also has internet access. Okay, so I've connected my rover to the wireless network. I'm going to SSH with the X forwarding flag to Swarmy at gamma. Okay. In order to calibrate the IMU, we're going to run code on the Arduino. In order to upload this code to the Arduino, we have to download the latest Arduino IDE. We can do that by using wget to this link, which has permanent archives of Arduino code. Alright, the code is almost finished downloading. It took about 3 minutes on this connection. Now that we've downloaded the IDE, we can untar it with tar xf, extract file name Arduino. It takes just a minute to unarchive. There, okay, now it's unarchived. Now that we've downloaded the Arduino IDE, we're going to clone two Git repositories. The first is the original logic code that runs on the Arduino for the Swarmathon. The second is the calibration code from Pololu. So we'll use the calibration code to specify values that we then plug in to the Arduino code, to the Swarmathon Arduino code. Before we can load the Arduino IDE and connect to our Arduino board, we have to deal with a quirk of Ubuntu, which is that there's a built-in modem manager that will try and control the Arduino. We need to disable that control before we can load the IDE. So here is the line of code that does that. It looks long and complicated. All we're doing is adding a rule to the UDEV rule set that tells the modem manager to ignore the board with this ID, and this is the ID for our Leonardo board. Now that we've added that rule, we'll need to update the rules with sudo udev admin. Okay, so now we're ready to run the IDE and load the calibration code. So first, we'll load the calibration code by browsing to it here. It's under LSM303 Arduino, LSM303 examples, calibrate, calibrate again. This is the code we're going to be running. So now we can connect to the Leonardo board and get ready to upload that code. So we go to board, select Leonardo, and the correct port for your Arduino Leonardo. And the arrow button here will upload the code to the Arduino board and run it. Okay, the code's uploaded. Once the calibration code is uploaded and running, we'll click on this icon, which is the serial monitor, to see the output. Okay. These values indicate the minimum and maximum magnetometer readings from the IMU. This is what we're going to use to calibrate our rover. So this is printing over and over and over again. The last line is the most recent value that it's seen. So I've now picked up the rover, and I'm going to rotate it in every axis possible. So I'm going to roll it over side to side, on its back. The idea is to try and explore the whole range of motion so that we can find any magnetic interference. And as I turn it, you can see the min and max values change. Okay, so I've rotated in every possible direction now. Once I'm satisfied that I've explored the whole space of magnetic interference, I can take this last line of values, and I'm going to use that to parameterize the Arduino code on the rover, so that when it's moving through space, it will normalize the values it gets from the IMU using these min and maxes. So once I'm satisfied that I've rotated the rover in every direction, I want to copy these min and max values and use them to normalize the Arduino code, the Swamathon Arduino code. So the first thing I want to do is turn off auto scroll so that I can select these min and max values. Control C to copy, and I'm going to put them temporarily in a text editor. Next, I'm going to open the Swarmathon Arduino code so that I can edit it and put in these values. So let's close this, file open, and the path is Swarmathon Arduino, and there's the source code. So I opened it back here. And now I'm going to upload that code to the Leonardo. Okay, that's finished. The lines of code that we're going to edit are in the setup function. So I'm just going to find that quickly. Here it is. And here are the lines that set up the magnetometer. And you can see that these are divided into the min values and the max values, just like we have here. So I'm going to enter those values. So here we have minus 2160, $39.33, $32.17, and the max values, I'm just going to cut and paste them. Okay, so now we've set our normalization factors for the magnetometer. Now that we've calibrated our rover, the last step is to upload this code onto the rover with these modifications. And that is it. We've successfully calibrated our rover, and now we can use the IMU to localize its location at the nest or at targets with much more accuracy.